All right, folks, welcome to another warmer than average weather and climate office hour. Warmer than average being a bit of an understatement in recent days, of course, across a lot of the western US and now increasingly also the central US and yes, even the eastern US. So, what was originally an extreme and record shattering, yes, record shattering, western US heat wave really has expanded to encompass much of continental North America in the past few days, and believe it or not, unfortunately, is about to resurge in intensity across the West. In some places, this, I would almost say the second peak, really the tertiary peak or quaternary peak, depending on how you're counting, will be almost as intense as the most intense wave thus far. Not everywhere. Coastal California probably won't get quite as hot as it was, but temperatures still well above average, still even into record territory, just not in monthly record shattering territory in some parts of the coastal region. But it is actually going to get warmer again this week in a lot of California and dramatically warmer once again across the interior West. And that is not what we really want to see right now, following what has already been the warmest winter on record in many places, what has unquestionably been the warmest March to date on record after the winter formally ended at the end of February, astronomically anyway, or meteorologically, I should say. But the challenge is that we got at least another week of hugely anomalous heat across most of the western U.S. More than a week still. In some places, we still got another 10 days of this to go in some places. And Snowpack is taking a nosedive from near record low levels to begin with to what are now pretty clearly record low levels across a widespread part of the West. I'll talk more about that. I will talk about how there is a little bit of good news on the longer weather time horizon time scale. So we're talking about really maybe a 3 to 7 day window centered on early April, when it does look like this darn ridge will finally, or at least temporarily, go away across the western U.S., replaced by a transient trough. It doesn't look like it's going to be particularly intense or persistent, but it does look like it's going to be enough to cool things down, not just below record high temperatures, but even close to March average temperatures. Imagine that. There might even be a day or two slightly below the recent average. It certainly won't be dramatically cold, but there will probably be some precipitation, at least in some parts of California and the West, so it beats weeks of record heat, I suppose. It does not look like it's going to be anything resembling a rescue pattern from this extreme drought. It just looks like we might get a week of near average precipitation and maybe, if we're lucky, a week of closer to average temperatures before things dry out and warm up again, probably thereafter. So it's more of a reprieve, and I know a lot of folks who are on this particular kind of live stream probably intuitively have a decent understanding that a week of rain and average temperatures does not in any way negate weeks to months of record-shattering heat and low snowpack in terms of the hydrologic and wildfire-related impacts, but it does bear repeating because I get these kinds of queries all the time from people and from journalists. When it rains briefly or when it cools down for a little while, there will probably even be some high mountain snow in early April, and it really won't change anything about the picture in the medium to long term, unfortunately. So yes, you'll get a bit of a break. Things will feel a little bit less conspicuously weird, but we're in a pretty dangerous territory, I guess it's fair to say, in terms of western snowpack and water supply. Not every region experiencing the same level of threat. California, again, as I've been talking about, is in a better position, relatively speaking, than much of the interior West, as are places like Washington State and the northern Rockies, so the northern part of Idaho and northwestern Montana, mainly because this snow drought has not been accompanied by a particularly significant hydrologic drought yet, because precipitation has remained near or even above average in those locations, despite the record or near record warmth and extremely low snowpack. But the interior West, the Rocky Mountains, the Colorado River Basin in particular, is in trouble right now, and I'm going to point out some of the statistics specifically that support that. So just want to remind folks once again that this channel is sponsored by Reask, a climate tech company that's helping rethink extreme weather and natural hazard risk in a warming world. So it was another hot weekend across much of the country, really, with many places all the way from Southern California to east of the Mississippi River, even into the Appalachian Mountains, setting all-time record high temperatures for the month of March. In fact, it was so extremely hot, and I mean, I'm comfortable using the term hot. It wasn't even just warm in relative terms, but it was legitimately hot. Temperatures exceeding 90 or even exceeding 100 degrees. Literally 100 degrees or more. In a few places, even exceeding 110 degrees in the desert Southwest, setting new all-time North American and U.S. national maximum temperatures for the month of March, in a lot of places exceeding even the records that were set for the month of April, which of course is climatologically a warmer month with longer days and warmer air temperatures, so that's an incredible margin. There's even a few locations that broke their May temperature records. Again, we are in mid-March. It is very difficult for the atmosphere to achieve that level of extreme heat with days as short as they currently are, with the sun angle as low on the horizon as it currently is. Usually it takes longer days and more intense sun closer to the summer solstice to pull that off. And in many cases, some of these temperatures are being achieved in places where there's even still snow on the ground melting, which is really working against those extreme surface temperatures as well. But it happened regardless, and this has probably turned into one of the most extreme heat anomalies in the historical record for the western and central United States. It's up there with March of 2012, for those who remember that one, and June of 2021. It does not mean that temperatures were actually higher in absolute terms than June 2021 in the Pacific Northwest. That's the event where it reached 116 degrees in Portland, Oregon, and 108 degrees in Seattle proper, and 120 degrees Fahrenheit or higher in the glacial valleys of British Columbia, if you remember just how extreme that one was. But it means that the anomalies, the departure from what would typically be the case at this time of year, was just about as large as it was during these other record-shattering events. So if we measure temperature anomalies as a departure from what you'd usually expect in a given place at a given time, so in other words, if we're comparing apples to apples and oranges to oranges, this probably was one of the most singularly extreme heat events in an anomalous sense that we've observed in North America in modern history. So, and it's not over yet. And part of what is making this event so extreme is it wasn't just a really short but intense burst of heat, but it's gone on for weeks, and it's going to go on for at least another, in some places another 10 days. So it's not over yet. The impacts are not fully told yet. And even when it cools down in April, and I'm telling you that it will, and it'll probably rain, and there might even be some mountain snow in April, because of course it's still April. It's easy to forget that with how hot it's been. We have experienced an event that doesn't have historical precedent in the western U.S. There has never historically been a year even close to this year in terms of how warm the winter has been, and what the divergence between stream flow on many of the West's major watersheds, so thinking about, for example, the Colorado Basin in particular being sort of foremost among those basins that I would be thinking about in this context, but it's also true of others, that because we've seen such extremely warm temperatures all winter, but now put an exclamation point on that in March, with record-shattering warmth, statistically record-shattering, meaning breaking historical records by wide margins, and not just merely the record warm winter, but followed by an even more extremely anomalous warm period thereafter. I think that a lot of the historical heuristics that we use to estimate Western water flow, Western snowpack, may be in a position to underestimate just how much this recent heat has affected or will affect stream flow and snowpack moving forward. Because we've never before experienced this combination of Not extremely low precipitation, but absurdly record-shatteringly high temperatures. We've never before seen a snowpack that across virtually all regions in the West simultaneously takes a nosedive. And by a nosedive, I'll show you what I mean in the graph in a minute, but it literally is the curve going vertical in the wrong direction, right at the time of year when snowpack would historically be nearing its peak. In most Western watersheds, the snowpack peak in a typical 20th century year would have occurred between about now and the first week in April, so late March, early April. That's why April 1st snowpack is often used as a really important indicator of water supply and fire risk and lots of other things in the western US. This year, the March snowpack is doing something that it really hasn't done before on a widespread basis, to my knowledge, ever in recorded history, which is plummet. Not just level off, which would already be a concern in a year with snowpack that was near record low to begin with, but actively decrease at a rapid late spring or early summer-like rate. That is what I don't really think we've seen before in March, and what leads me to believe that we will probably be seeing all-time record low April 1st snowwater content in many basins, if not most basins in the western US. There will be some exceptions, certainly in the northern Rockies, and there might be a couple of really high elevation sites in the southern Sierra, for example, that managed to eke out a non-record low snowpack on April 1st, but pretty much everywhere else, I think, is fair game. And some lower elevation basins, I just want to point this out, some lower elevation basins will have completely melted out or be in the low single digits with like 1 to 5% of average snow water equivalent by April 1st. In fact, there's already some basins, I'll show you today, that have less than 1%. Now, granted, right now, these are mostly lower elevation basins with lower background SWE, but I think as this record-breaking heat wave persists for the next week across much of this region, I think we're going to see further declines at more moderate elevation basins and also further declines at high elevation basins. So that is a significant concern moving forward, because I just don't think that we've really seen the full extent of the snow losses that we're going to see in the coming days. It's not over yet. And I'm actually just pulling something up right now because I have a lot of figures I wanted to show today, and I just essentially neglected to actually pull up one of these on the screen preemptively. So I'm just trying to do this so that I don't forget. Just trying to download the most recent, yes, since I generated several versions of these, and I just want to make sure. Yes, here we go. Okay, so that's what I needed today to show everybody, since I wanted to just show one more piece of perspective here in terms of the long-term trends. All right, there we go. Finally, these are up now. So I just downloaded the same figure twice. This is what happens when you do it live. I would have done this not live, except that there just aren't enough hours in the day. Okay, so let's start today with I got a lot of figures I want to show in so little time, so let's start with, okay, I'm going to share my screen. That's probably what I should start with. Okay. So I just want to show folks where we are again today. This is the current map of record-breaking temperatures, and like every single day for recent weeks, there are a lot of places already breaking record high temperatures today. In fact, in California, there are once again places all the way from the Bay Area to the Lake Tahoe region, to the Central Coast, to the southeastern deserts that are nearing or already have exceeded daily record highs at 2 p.m. I believe this map is for 2 p.m. Pacific time. And there are places in Utah and Arizona that are once again not only breaking record highs, but breaking all-time record monthly highs. from any previous year prior to this year, although because these records have been broken so much over the past week, I don't know if it's necessarily breaking the new record set last week, but it certainly is exceeding temperatures seen during any previous week in any previous March going back for the full period of record. And the other thing is that we just have some other casual monthly record-breaking places in the coast of Texas, and I think in the Carolinas as well. So again, a wide distribution of heat, and this isn't even peak heating. I'd expect this to sort of expand across more of the West once again today, and then expand across even more of the West, re-expanding as this ridge expands over the next couple of days. Just to get a sense of what this looks like, or what this has looked like, well, actually, I think that map is a little bit too small for the screen to share. So let's instead show, this is a nice plot from the Southeastern Regional Climate Center showing for the past month, what is the rank of average temperatures? In other words, the units here are ranks. They're over here on the right side. So essentially showing what the rank relative to since 1895 of temperatures. Well, I guess in the period of record, so not all these cities have records since 1895. But in any case, for the full period for which we have records in a given observing site, how does the last 4 weeks rank against all other such 4-week periods from late February into late March historically? And the answer is pretty much everywhere where I'm drawing my blue outline, more or less with just a handful of exceptions within there. This was the single warmest such period on record. And I just want folks to reflect on how enormous a region this is. This includes almost all of California, including the coastal cities, San Francisco, LA, San Diego, Sacramento, all of the Central Valley cities, and Lake Tahoe. So just about everybody except for a little bit of the North Coast, and even there it was still the second ranked such period on record, extending eastward across almost all of the Great Basins, all of the desert Southwest, almost the entirety of the Rocky Mountains, all the way from northern Mexico up into southern Montana, eastward across the Great Plains, and even further eastward to the other side of the Mississippi River, east of Arkansas, and all the way down to the deep South Texas, essentially at subtropical latitudes. This is an extraordinary feat to have achieved over the course of a month. And just for perspective as well, in a lot of these cases, this record was obliterated. It was not broken by a narrow margin, but the second ranked event isn't even close. So this is an extraordinary measure. And the other thing too is that even though it hasn't been record-breaking warmth in the eastern U.S. to the same extent, it's still been way warmer than average. In fact, there's a lot of places where this period, even in the Ohio River Valley, the Appalachians, and even to the east coast, so the Atlantic seaboard in the Carolinas, where this was one of the top 3 or 4 ranked such periods on record. So for all of the headlines about cold, I mean, this map does not connote a period where anyone has really been experiencing exceptional cold. It's very much, in fact, the opposite. Which brings me to what my big concern is at this point, and that is regarding snowpack. And this map just keeps looking worse and worse every time I glance at it. But just for perspective now, here is a map of all individual snow observing sites, and everything that's below 50% of average for the date is in red. And again, most sites in the western U.S. are in red. There's a handful of very low elevation sites in the southern Sierra that are not, but at this point, even the rest of the Sierra Nevada and all of the northern mountains are now well into the red. Almost every site in Utah, almost every site in Nevada, every site in Arizona, every site in New Mexico, almost every site in Colorado, every site in Oregon, and almost every location in Washington, as well as many in portions of Idaho, eastern Wyoming, and southwestern Montana at lower elevations. Another exception region, again, is the highest elevations of the northern Rockies up here, where wetter conditions, despite the warmth, has allowed for snowpack that is okay. Certainly isn't great. But pretty much outside of this poorly drawn region with the squiggles in it up here, every other location in the western U.S. has awful, abysmal, and in many cases, record-breaking snowpack. So previously, I could have carved out a narrower region. At this point, the only place that's left where it isn't really terrible is kind of up here. And just to really bring that home, I want to show locations where that are currently experiencing record low conditions. Just want to make sure that I'm still sharing my screen here as expected. Yeah, there we are. Did that? Yeah. Oh my God. Yeah. I honestly, I thought I hadn't. I thought I hadn't changed the toggle switch, but I did. Wow. So I am on records. Now, notice the units on the left have changed. Now we're looking specifically at places that are either either their largest snowpack on record or their second highest, or their lowest snowpack on record or their second lowest. And now obviously in the US there's no places that are highest or second highest. There are a whole darn lot of locations that are at their record lowest or second record lowest snowpack. In fact, at this point, in Northern California, a majority of stations are experiencing either their lowest or second lowest snowpack on record for the calendar date, March 23rd. The same is true of Oregon. Almost all locations are record low or second from record low. Almost all of Nevada, record low. Almost all of Utah, record low. Almost all of Colorado, record low. And yes, it looks like all of Arizona and New Mexico. They don't have as many sites, but they're essentially all at record lows. This is what I mean by unprecedented spatial coherence. It's not just the Sierra Nevada that's really low. It's not just the Wasatch. It's not just the Southern Rockies. It's not just the Cascades in Oregon or the Great Basin in general. It's all of these regions all at once. This is not just a map showing below average. This is a map showing places where conditions are literally the worst they've been in the full observed period. This is where the spatial statistics come in. It is far more remarkable that this is happening across such a wide region than if this were just occurring in one or two subregions. It would be bad enough for those basins if that were the case. But think about where the Colorado River Basin is, and I'm drawing it, very poorly here, but in general, you get the idea. Pretty much the whole headwaters of the Colorado Basin, except for some of the very few sites up in the far northern headwaters, are experiencing record low or second record low snowpack. And these numbers are going to get worse before they get better. In fact, I pretty much at this point expect everything south of about here to saturate into the red. The remaining dots will probably turn red by the time we have maybe a circa April 1st update. These numbers are highly alarming. And to think about this in terms of basin conditions, this map really tells the tale. Nowhere really is doing great, and everywhere in red is doing terribly. And some of the places in orange are also actually at record lows. It's just harder to get those values this time of year. The other thing I want to point out, this isn't just below average. In fact, below 50% of average doesn't quite do this justice, because some of these basins, 0%, 0%, 0%, 0%. And yes, these are relatively low elevation basins at low latitudes, but then we get up to other places like northeastern California, 9%, southern Oregon, and the Klamath Mountains, 6% of average, 0% up in some of the coastal mountains of Oregon, 6%. So we're not just, 7%, 8%. So we're not just talking about some of the really lower, hotter mountain ranges in the Southwest. We're really talking about, 0% here is also very concerning. That's not a low elevation basin right by the Four Corners. There's negligible SWE left right in the subbasin that includes the actual Four Corners region, for example. So, 20%, 30% numbers, 40 or 50% numbers are still quite alarming, but some of these are really getting close to having no snow left at all in the hotter, lower elevation basins. And I would expect to see more basins at or under 5% in this area, especially by April 1st, which is why I'm so perturbed to see these kinds of numbers. As I've been talking about, soil moisture is, in a lot of these basins, it's above average, but that's not necessarily good news. It mainly just means that the snow that would normally have melted later in the year is, it's melting during normal snow accumulation season. That's certainly what's true in the California mountains. This is true in the Great Basin. This is true in some of the higher mountains in the Rockies. So this does not mean that we're in great shape. It actually just means that the water that normally would have been entering these watersheds spring and summer is entering in March. But here we're starting to see the cracks in the armor as well, because that's not even true in all basins. We are starting to see some basins, for example, in the Southern Rockies Four Corners region that are actually below average even in soil moisture. What this essentially means is that so much of the snow has melted and it's been so hot that there isn't even really much residual soil moisture left up there. And the same thing is true up now in these far northern California basins into eastern Oregon as well. So, in some of the higher elevation, higher snowpack regions, we're seeing early snowmelt, and that's translating to high soil moisture right now. But eventually, this means that soil moisture later this season will likely plummet much earlier than usual. But what I really wanted to actually show here today are some of these basin plots. Here is the California average snowpack trace for the season, and you can see we've wrapped the rate of melt has accelerated as temperatures have really warmed into record territory. We're rapidly approaching the all-time record low level for snowpack for the time of year that was set in 2015. In fact, I would now expect we are probably going to be below the all-time record by April 1st. At our current rate of melt, we're going to end up being near or below 2015. Despite having vastly more precipitation this year, that snow is gone. But the real problem basin, I just clicked on the same thing. The real problem basin at this point is the upper Colorado, because this is a basin that is very snow dependent and is already experiencing a severe to extreme drought. This is the number that is quite concerning to me. And it is, well, actually, I'll just bring this up on screen. Typically, the peak of historical snowpack in the Colorado Basin is around April 6th, or about 2 weeks away. That would be about here on the plot. The very worst modern era peak, I guess I should say, some of the worst snowpack conditions we've ever seen historically sort of follow this red trace here. So as you can see, we started the season low, but within the range of what we've seen historically. And then we got to about mid-January, and then things started to diverge. We started to depart from the lowest observed levels. Through February, we briefly made it back up, maybe close to the record low. But look at what has happened since about March 10th. So over the past 2 weeks, this is what I mean by snowpack taking a nosedive. We are at really unprecedented territory, not just for what the amount of snow that's left is for March 23rd, which is now clearly a record low by an enormous margin. I mean, look at the gap between the previous record low for March 23rd, 10.4 inches, and the current value of 6.2. Again, 10.4 is the record low, March 23rd, modern era since the early 1980s value, and we're currently 40% below the historic record low value. Now, as folks have pointed out, this record doesn't go back that far. There may have been a slightly lower number for March 23rd than 10.4 back in like 1979 or 81. I forget which really low year was sort of competitive there. But the point is, that number was sort of in between this black curve and this red curve. But we're way on the other side of that at this point this year. And unfortunately, I see no reason why this precipitous decline won't continue for at least another week, because we expect it's actually going to get even hotter again in the Colorado Basin over the next couple of days. No precipitation whatsoever. So I wouldn't be tremendously surprised. I mean, here's April 1st on the plot. I would not be surprised if we end up down here by April 1st in this territory where the cursor is. So just think about how far that is from the previous recorded April 1st record low. I don't think we're going to sustain this extraordinary rate of snowmelt the rest of the season. It will likely at some point cool down. There will probably even be some additional precipitation, some additional snow, since remember, a considerable portion of this watershed is over 10,000 feet in elevation. So it should still be snowing, and certainly in March and even in April, and sometimes even in May. So I'm sure this will get this precipitous decline will eventually be arrested and stable flatline somewhere further along here, but I don't really think we're going to see meaningful recovery, which means that the seasonal peak this year in the Colorado Basin may have occurred around March 8th or March 9th. For perspective, that's essentially a full month earlier than usual, but more importantly, it's at an incredibly, vastly lower value. Because think about it, up here, 16 inches of snow water equivalent is the historical median. 16 inches. This year's peak will have been under 9 and has declined to an even more anomalous value in March. This is what I'm so concerned about this year. Colorado Basin, this is a combination we just haven't seen before historically. In California, as I mentioned, the situation is a little bit different. This is a nifty tool from Scripps. I believe this was originally developed by Mike Dedinger, and then Scripps has kept it up as an operational real-time tool. But this is essentially viewing California's water storage as the sum of the big 28 Western Sierra reservoirs plus the reservoir in the virtual reservoir that is Snowpack, because that Snowpack mostly melts and flows into the Western Sierra reservoirs in the spring and summer. That's how the system is designed. So California does essentially plan for the sum of reservoir storage plus snowpack content, and that's kind of what this curve is expected to look like. And you can see that the curve is historically at its greatest divergence sort of around April, when the snowpack peaks and the reservoir levels are still going up. But look how different this curve looks this year, and you can see the effects of this current heat wave. Here's what I mean about the nosedive. The reservoir levels are doing okay. In fact, reservoir managers are sort of keeping them topped up to the greatest extent that is safe from a flood risk management perspective. You can't just bring them up indefinitely, or you lose your flood control storage. But they are keeping them consistently above the average level for the time of year. And we actually, around January, peaked with above average combined snowpack plus water storage. But now, in February, we fell below, and despite the big February storms, we've now seen a really precipitous decline. And again, I'm expecting this curve to kind of look like this through April 1st. We may get to a point where on April 1st, almost all of the water that California has access to is going to be the water that's in the reservoirs, which I expect will probably look like this. So I kind of think these curves at some point may more or less meet. Once this curve meets this curve, it means there's effectively no meaningful snowpack left to recharge the reservoirs, and we've got what we've got for the rest of the season in the reservoirs. The good news is what we've got in the reservoirs is pretty good. The bad news is that's pretty much all we're going to get. We're not going to get much in the way of combined virtual reservoir capacity this year because of this. And there's some other cool tools on this page, but if we look specifically at Northern California, we actually see we're already close to that point of convergence now. The gap between this blue and this orange is pretty much how much water is left in the snowpack in these regions. So if we look at Northern California, there is vanishingly little snowpack left to contribute to the reservoirs. In fact, by April 1st, I think we will have converged. I think that pretty much it's going to be one and the same. There will be no meaningful snowpack left in Northern California by April 1st. Yikes. Now, the good news is, again, reservoir levels here's the average, they are above average because reservoir operators are aware of what's going on meteorologically, so they can make some informed decisions. But they can't let this go infinitely high because, again, there is a top on the reservoir. There is a maximum reservoir level that's physically possible, and there's also a maximum reservoir level that's safe and legally mandated for flood control reasons, because it is technically still the rainy season, and we could technically get a significant storm still in April or May. And I'm not saying it looks likely right now, but if it were to happen, we have to manage reservoirs accordingly. So I would not be too surprised if we level off with a convergence right around here. Again, that would be fairly extraordinary. All right, so a couple of other interesting statistics just to point out. Flagstaff, Arizona is probably the single location that saw the most extremely anomalous, record-shattering heat during this event, if you will. For perspective, this event was the most anomalously extreme heat event ever observed at any time of year in Flagstaff. So at the high elevations in the southwest, right at the center of this extraordinary record-breaking ridge. This does not mean that it was hotter this month than it would be during a heat wave in July, but what it means is the departure from what temperatures would usually be like at this time of year was greater during this event than at any previously observed event by a pretty wide margin, I would add. And the other thing is that we've had multiple days that were either at the top or above the top end of the anomalous temperatures that we would have expected from this sort of heat wave. And this is just continuing. Flagstaff again breaking its all-time monthly record high again today, as it will perhaps for days to come. This heat wave is extraordinary. And just to again point out, Flagstaff is a high elevation site, 2,100 meters. I mean, that's I'm trying to do the math. That's 7,000 plus feet. I forget exactly what Flagstaff's elevation is. This is not even a medium elevation site, but this is a legitimate high elevation site. And the anomalies we're seeing during this event are really just outlandishly large. Here's a nice visualization from Dakota Smith. And this is just showing, let me rewind it. This is the ridge itself, this big red blob, and you can see all these atmospheric rivers going up into British Columbia and into the Pacific Northwest, up and over the ridge. You can see how the atmospheric rivers are injecting all of that moist air, all of that energetic air into the ridge on its eastern and northern flank, and the air is drying out, but it's sort of heating by compression, and all that moist static energy getting ingested. You can see this cutoff low try and make it to California, but it falls apart and just brings some clouds. You can see how the pattern all the way out to the southwest by Hawaii then is connected with what's going on in the Pacific Northwest, which is connected with what's going on in the central U.S., which is connected once again retroactively through retrogression, literally east to west flow at the bottom of the ridge of what's going on in California in the southwest in this malevolent color scheme, this bright red and orange and brown blob. That's the ridge, and this is going to be a feature that sticks with us. We could make an animation forward in time a week and it's going to look similar. This has also led to what is a pretty extreme marine heat wave at this point. Here are the current departures from average, or at least as of yesterday, and you can see the region of rather extreme heat anomalies has developed from about the southern tip of Baja California up to about central California. These water temperatures are conspicuously warm. This is now a moderate to severe, or even extreme in some cases, marine heat wave. Just to point out, here are the temperatures off the Scripps Pier, and we've actually seen record daily high temperatures as far back as February, so it's actually been much warmer than average all year. In fact, if you look at this trace, here's average for the seasonal average at the time of year, and here's where we've been in the blue. I mean, we've already been way above average. We had a cluster of records back in February, but now, again, record-shattering. Look how high this value is relative to the average water temperature this time of year. And also, look how far outside of the range, if you kind of draw a smooth line, for the most extreme temperatures we've previously observed at a different time of year, there's a smooth version of it, we're so far above that curve. In fact, the current water temperature off the Scripps Pier in San Diego is so extreme that it would actually be essentially equivalent to the highest water temperatures you've ever seen in June. It's March. So again, and actually, as I would emphasize, the current water temperatures off the Scripps Pier are above the average water temperature in July and August. So currently, we have record-shattering ocean warmth near the immediate nearshore conditions in Southern California that are equivalent to all-time record warmth for June, let alone March, and not that dissimilar from average, or actually warmer than the average temperature at the peak of the season from August to September. So again, just bonkers numbers. And again, it's not over yet. Okay, so here is where I do have some. And I did want to offer one quick correction, actually. I showed some Snowpack plots. I believe it was in the last live session. They were wrong. I made a mistake. This is what happens when I try and share things in rapid fire when there's not a lot of time to prepare them. As always, what I'm presenting in these sessions is not necessarily the equivalent of peer-reviewed research. I do try and draw upon peer-reviewed research as much as I possibly can, but sometimes when you're talking about real-time data in the moment, there just isn't the ability to do that. But I did want to point out that the plots I created last time and showed for long-term trends in California snow water equivalent, there was an error in the underlying data. So I want to point something out. I've separated again California's long-term trend. This is in the SNOTEL era, so this is essentially in the era when we have automated snow sensors across most of the West. There are some snow observations from before that, but they were more ad hoc and less systematic, so I'm focusing mainly on the post-1980 period, and it's also the period when we've seen the most warming in the West anyway. The warming prior to the 1980s was more modest than what we've seen since then. But I just want to point out that there's less of a difference between higher elevation and lower elevation sites than I previously claimed. So actually, the amount of snowpack loss in the Sierra higher elevation versus the Sierra lower elevation is roughly comparable. It's on the order of 20 to 25%. So think having lost about a quarter of the snowpack since the early 1980s in terms of the average snow water equivalent. But also, the other thing I really want to point out as I toggle back and forth between these two things is just how much more common the really low or 20th percentile snow years have become. Everything circled in yellow is a 20th percentile snow year, and everything not circled in yellow is not. There were a few in the early part of the period, but look, many of our most recent years are low snow years, both at high and at lower elevations. There's been a large increase in the fraction of years in which we see low snow conditions. In fact, it's gone from about 10% to about 30% of years, or about 15% to about 30%, so nearly a doubling in the fraction of years that are considered low or very low snow years, I'd say, because it's not just below average, but falling into the lowest fifth of the historical distribution. This year is destined, of course, to be one of them. In fact, it already is at the lower elevation sites under 6,000 feet. This number is just a placeholder. This is my guess. I used the current value for March 20th for this point, but of course the real April 1st value, given the forecast, will be even lower, so this will drag the long-term trend down even a bit more. But my point is, I just wanted to make sure that I was fully transparent, that I made a mistake in this rapid fire plot. It doesn't reverse the fact that we're losing snowpack over time. It doesn't reverse the fact that there is a significant loss both at lower elevations and in higher elevations, but the main thing it does change is the specific numbers I mentioned, and it also does affect the narrative regarding the greater loss at lower elevations. It actually is more similar in terms of, at least in terms of the percentage loss overall. The other thing I also wanted to point out, and this is especially true at higher elevations in this plot here, is this sort of emerging trend towards, I don't know a better word other than snow whiplash, because we actually see that the lowest years have gotten a lot lower a lot faster than has the average, and that's partly because the snowiest years are just as snowy as they've ever been. In fact, one of the snowiest years on record that it gets cut off up here was in 2023. So this trend is actually muted because what we're actually seeing is a rapidly increasing divergence between really low snow years down in this territory and really high snow years up here. The really high snow years haven't really decreased, but the really low snow years definitely have, which results in a bit of a muted trend in average. If you've ever seen my discourse on precipitation in general, I beg people to look beyond the mean and think about how the extremes could be doing something very different. And this is an interesting emerging example. The data I downloaded over the weekend actually looks like much of the West is showing a similar pattern, with robust mean decreases in snowpack and very large increases in the worst snow years, but either non-decreases in the snowiest years or in a few high elevation locations, an increase in the very snowiest years, at the same time that the very least snowy years at the bottom end of the spectrum are doing the opposite. How can this possibly be, you ask? Well, it's because of the competing effects of temperature. The most intuitive one, as it gets warmer, your precipitation is more likely to fall as rain rather than snow. It melts, essentially. And so you get the precipitation, but it's no longer falling as snow anymore. It's rain, and you don't accumulate in the snow water equivalent. That's the dominant effect driving this long-term trend, and in particular, the increase in the lowest snow years. But on the other end of the spectrum, in a warming climate, where and when it is cold enough for significant snowfall, we actually see, at the very highest peaks in the most extreme storms, we don't really see any loss in those most extreme snow events because a warmer atmosphere can hold more moisture and therefore have heavier precipitation in a warming climate. If it's cold enough, even if it's marginally freezing, that 7% increase per degree Celsius or 4% increase per degree Fahrenheit of warming is actually going to lead to heavier snowfall where and when it is cold enough. So all else equal, long-term mean trend dominated by thermal warming and the loss of freezing temperatures, but in the tails of the distribution, the snowiest snow events remain pretty darn snowy. I'll have more to say about that later, but I just wanted to offer that adjustment and correction here. So I know what a lot of folks are interested in is the forecast moving forward, so I want to get to that now. Here, I'm going to zoom in a little bit. Is a map from Tropical Tidbits, Levi Cohen's cool website, but here is just showing where we were with the big ridge in the southwestern US. This is going back in time to Thursday last week, this gigantic high pressure system in the southwest anchored with all of those record high temperatures last week. It continued through the weekend. As I mentioned, there was a little bit of a wave break where this weekend the northeastern flank of the ridge weakened and we got some cooler weather in the Rockies. But now, as we go forward in time again, this is now going into tomorrow, Tuesday, this ridge rebuilds, unfortunately, into quite extreme territory for March. This is once again a big angry red splotch covering most of the western and central U.S. We will see more record temperatures and, yes, even more all-time record high temperatures. In fact, some parts of the interior west and central plains may even break some of the all-time records they previously broke last week. Once again, if I seem like I'm getting a little out of breath, well, it's been a long month. As we get into later in the week, this is now Thursday, we see this ridge elongates and expands. It weakens somewhat over California, but remains and expands eastward across Texas and the Great Plains, and once again sort of rebuilds and re-strengthens over the Rocky Mountains. So, we're 5 days from now, we see a fourth rebuilding of the ridge centered right over the Colorado River basin and the Four Corners. Again, this is why I'm so concerned about the upper Colorado snowpack. And it kind of just keeps sitting there and not really relinquishing its grip until about a week from now. So as we get to the very end of March 30th, things may start to change. You may notice that there's no longer red west of California, but there is in fact a weak trough. Finally. As we get toward April 1st, you have to squint and you miss it a little bit, but it's not a deep trough, but it is technically a trough nonetheless. The ridge axis now shifts eastward in the central U.S., and then California on the west coast is actually the axis of a weak trough, the opposite of a ridge. Hallelujah. And then, as we go into early April, we might even see a bit more of a distinct troughing signature. Again, nothing dramatic or extreme. It's a pretty weak trough, but it's the opposite of a ridge. So that may be what we need for finally some relief. We're getting into April 3rd now. We go out beyond April 3rd, and it's less clear what happens next. It actually looks like we may see some ridging build back in again by the end of the first week in April. It does not look as extreme, but it doesn't look like the consistent cool or wet pattern that we'd really want to see is in the cards. But we might see cooler weather and some precipitation, at least in the meantime. So if I zoom in to the western U.S., let me zoom out a little bit here on the page. What we see, it's funny that there's an osteoporosis commercial on the right side. Well, I guess you get secondhand advertising. This is a challenge of when the data access is not publicly subsidized, as it could be through high quality public data visualizations. It's the the people who are maintaining these websites to provide it on their own dime and on their own time, you gotta let the ads run sometimes. That's just the practical reality of it, and I'm grateful that the data visualizations do exist. So thanks again to the site proprietors. All right, so looks, as I mentioned, completely dry in California and most of the West through 7 days from now. So we got to go a whole other week before we even start really talking about precipitation, unless you're in Western Washington, and then it's, Washington has been the exception for much of this winter to what we're talking about the rest of the West. But if we're talking about California, the Great Basin, the Rockies, next full week looks completely dry and looks just extremely warm. This is the next 5 days on average. There's the next 7 days on average. Once we start getting, as I mentioned, toward early April, this starts to shift. Not dramatically, the heat shifts eastward and fades. And we finally get to a point where in California, it's not really colder than average, but it's close to average. Finally, we get rid of the bright reds and pinks. We may even see a day or two of below average temperatures. But what does this mean in terms of precipitation? Well, as I mentioned, the next week, drier than average, dry as a bone almost everywhere. As we shift towards early April, it doesn't look anomalously wet across the West, but we get rid of a lot of those yellows, and we get close to seeing it's mostly near average precipitation. So I think what's probably going to happen is we get a 5 to 7 day period of near average precipitation and near average temperatures in California and the Southwest. It's going to feel cold and damp by comparison to recent weeks. It won't be all that remarkable by the standards of April, because we're at the time of year when average precipitation starts to decrease, but it will be decidedly much less warm than it has been. One challenge, though, is that these really warm near-shore temperatures near the coast of California are going to keep the coast of California much warmer even without a ridge. So I actually think the models may be underestimating how much residual warmth will remain along the California and Oregon coast during this pattern, and any precipitation that does fall over the mountains, it's going to be really hard for it to fall as snow. These are not going to be really cold air masses, and they got to traverse a really anomalously warm ocean. So unfortunately, I don't really see much prospect for more than incidental dustings of snow. This is not going to rescue the snowpack in any way, shape, or form. But I will say, this is the model cycle from last night. For the next 2 weeks, precipitation is not zero, but this would be a decent soaking along the north coast and the northern mountains in the Sierra, mainly as rain, by the way, and also a decent soaking for the southern Rockies. But again, this is rain, not snow. It's just too warm. But it would be cooler, and there'd probably be some snow on the highest peaks. The most recent update cycle from later today is a bit wetter, and we'll see if this trend continues. This would be a slightly more significant early April rain event for Northern California, but we'll see if that continues, because if we look at a different model, for example, that's the European model, this is the American model ensemble, it's kind of splitting the difference. It's a little bit in between. So just to point out, this is not a remarkable amount of precipitation for early April, but it does suggest we're more likely to end up in a better place than we've been in. And just to further drive that point home, here is kind of what we're looking at. Here is the full ensemble for a point near Davis. I'm running out of time in the hour, so I won't describe this plot in great detail. If you want some context, check out the last session where I described this in detail. But it looks like right around April 3rd is the best bet for some Northern California precipitation. There's a slight chance of some showers earlier around April 1st, but many of the members in the ensemble are dry. But it looks like most members have a meaningful rain event somewhere around April 2nd, April 3rd. Again, nothing extreme, but some of these do produce a decent amount of precipitation, a good soaking rain. And then as we go toward the end of the first week in April, things dry out during this period, and there's a little bit more range. Most members are dry, but some of them do continue some residual April showers. If we go down to LA, though, we see that in general, prospects are not as good. There is a chance, there's about a 1 in 4 chance of a decent soaking rain event right around April 3rd once again, but there are quite a few members that remain mostly or nearly dry during that period as well. So the odds are much better in Northern California. They're not zero in Southern California, but they are lower. The other thing I would point out too is that the cumulative precipitation, it doesn't look too terrible. In fact, the likelihood that there's at least some precipitation during this period is actually now very high. Almost all members, but, well, 1, 2, 3, 4, 5. So about 10% of members bring essentially no rain to Northern California all the way through early April. But now that is now the least likely outcome. Now it looks like there will be probably about maybe a half an inch of rain in the valleys, maybe an inch of rain mixed with some wet snow at the highest elevations in the mountains between now and early April. It ain't much, but it is something, and it is improvement over the literally 0% chance of rain that's in the entire ensemble for the next week. So you can see a clear divergence right around April 1st, but it's not going to help those April 1st numbers. That April 1st snowpack measurement is going to be kind of grim. All right, so I think that's about time for me to bring up my face fully on the screen again. All of these sessions recently have run long, so but I know there's been a lot of newcomers, so welcome. I know there's been a lot of interest for understandable reasons, and do feel free to subscribe to the channel if you value these sessions. It's the easiest way to be notified when I do go live, especially if I'm going to schedule something live on short notice, as occasionally occurs. So do consider that. And also, you do have to turn your notifications on, which is a separate step from subscribing. I know it's a bit of a YouTube quirk, but if you really do want to be notified when I schedule these live streams, usually 1 to 2 days in advance, but occasionally more or less, that is the easiest way. I also announce them on social media. So I'm going to take a sip of water and then start going through the questions. All right. Starting at the beginning in chronological order. During some of the more active weather periods, I take breaks to look at the comments as they're coming in, but in these events where there's no ongoing acute disaster, I tend to go through the monologue portion and pick up the comments at the end here, like I'm doing now. Comment that it's already another day of record-breaking temperatures in Sunnyvale with 86 degrees. I mean, those just are really warm temperatures for March. I mean, that would be a pretty warm, not record-breaking, but a pretty warm summer day in Sunnyvale. And again, it's still March. Pat Fisher mentions, I camped in the Southwest for the first 10 weeks. Oh, 10 weeks. That's a long camping escapade earlier this year. And it was hardly cold. I don't know where you were, but the point is it probably doesn't matter where you were, because that statement is mathematically and meteorologically correct for virtually all of the Southwest across many of its elevations. And I think that's something that I've been hearing from a lot of people. I mean, getting a cup of coffee, getting a haircut, whatever it is around town at the grocery store, people really are talking about just how conspicuously weird it feels this winter, especially in the Mountain West, especially in places where it would normally be not only cooler, but actually cold, with snow and ice and things. Snow and ice have really not been much of a thing this winter, except in a couple of very intense individual bursts, very brief, interrupted, and followed by record-breaking heat. And the absence of that, some people might consider that kind of winter weather unpleasant. Some people really like that winter weather, at least to the extent that it exists as a foil or a contrast to the rest of the season when you decidedly don't have that kind of weather. This winter has really been lacking in it. And people up at 5,000, 6,000, 7,000 feet elevation in the Southwest and the Front Range in Colorado, New Mexico have been mentioning how, running air conditioners because you can't get the house to cool off at night, even with all the windows open because it's 75 degrees at midnight. I mean, that is a pretty astonishing level of warmth for March. Again, it's March. These are places when snow would more often be on the ground, sometimes measured in feet, but instead people are running air conditioners. There's a comment that the western U.S. basically didn't have a winter. Well, from a temperature perspective, I mean, the winter will have been the coldest season of the year still, so in that sense, the seasonal cycle is still intact. But yeah, I mean, this past winter did not have temperatures that were commensurate with any other historical winter on record, so it certainly didn't feel like winter. We did still get a wet season, though, at least relatively speaking, in the sense that, the winter still is the wet season. Whether or not it gets a lot warmer, winter still brings water, more or less water depending on where you are, but it certainly brings more water than the summer will, at least outside of the core monsoon region. Now, this may actually be a year where the core southwestern monsoon region actually does see more precipitation in summer during the monsoon than it did during this terrible winter. So that actually might be one very modest mitigating factor later this season if we have a good monsoon, which looks to be possible. More on that later. But yeah, I mean, this winter has just, everything about what we've seen has just been, again, conspicuously weird, noticeably off is the language that I keep hearing people use. Just reading some more of the comments here. Yeah, I've heard from a lot of folks, including a bunch of fire folks and some of the UC ANR fire advisors, that the grasses in most of California, especially outside of the north-facing slopes, are curing, so they're turning brown. And a lot of places, for a lot of the grasses that are prevalent in California, once they brown, they're done for the season. There's some species of grass in the western U.S. that can recover and grow again if there's a subsequent wet and cooler period. But for the most part, a lot of the seasonal grasses, once they cure, they're done for the season. So we are starting to see increased grass fire activity. Nothing alarming, because again, the other vegetation is still pretty green and pretty full of moisture, because again, there has been a decent amount of soil moisture this season, but that's going to start to change too, unless things become dramatically wetter in April. And again, it probably will rain a little bit, but really not enough to change that big picture, at least not right now, as it appears. There's a question from Sam, would reservoirs be tapped into for extensive wildfires? Well, yes, in terms of water for water dropping helicopters, for example, or the type of aircraft known as super scoopers. These are the kinds of prop planes that will actually, believe it or not, they will land on the water, and as they continue to move, essentially like touch and go type situation, they'll skim the top of the water, scooping up the water, hence the name, and then immediately take off again. So during a wildfire, there's really two ways that reservoirs in general are used to fight them, and it's when water dropping aircraft, which in this country are mainly helicopters of many kinds, which typically drop water and not retardant, and then a limited number of actual fixed wing aircraft. Most fixed wing firefighting aircraft, if they're doing drops of some fire retardant material, it's actually a slurry, that red or pink slurry of fire retardant, and not pure water. That's typically not, except in the case of super scoopers, because the super scoopers will occasionally show up. But the other way, of course, is, to the extent that you have wildland firefighting going on via ground crews. So if you have, water tanker trucks driving around, or engines, or if a fire makes it into a populated area and you have hydrants, the municipal water supply, of course, all of that, or most of it, is usually drawing upon water and reservoirs. But I think this is a point that people often miss, is that when we only look at reservoir levels, when you think about ecosystems and landscapes and wildfire conditions, the amount of water in a reservoir doesn't really affect the fire risk. So you can actually have very high fire risk in a region that has overly full reservoirs. In fact, that's exactly what happened during the January 2025 fires. I know there's been a lot of focus on this tiny reservoir near Pacific Palisades that was empty due to the need for repairs, or at least reduced capacity. I don't remember exactly, but that's a tiny reservoir. The problem in LA during that event was not that LA didn't have enough water. That's just ludicrous. The water levels in the reservoirs on average were well above average. The city there was no long-term drought, no water supply issue. And yet wildfire conditions and the short-term flash drought type dryness had reached a record-breaking level at that point. So here there was enough water available, but you can't just magically make the water in the reservoirs be redistributed across the landscape. Wildfires can be 10, 50, 100 miles on a side, and the amount of water that's in a reservoir, even if you could magically teleport it, to connect this session with the last one, the theme of teleportation, I won't say more about that in this conversation, but even if you could magically apply all that water across, hundreds or thousands of square miles of a large wildfire, it would be almost a trivial amount, even if it were able to be distributed across the whole region. I think that's what we forget, is that reservoir levels, they're mainly relevant for telling us about water supply for people and for agriculture. They don't really tell us anything about what's going on at landscape scale. They don't really tell us anything about wildfire risk, because the landscape can dry out to extreme levels even if reservoir levels are near or even above average. And in fact, I expect that is a condition we will likely see this year. I suspect that in places like California, we may see major wildfires burning right next to reservoirs that are fuller than they would usually be, at least in the first half of the season. That's going to be quite possible. So it is also true that operationally, from a firefighting perspective, that if you do really run low in terms of really low reservoir levels during severe droughts, or individual ponds or lakes that might run dry, then that does become an additional fire hazard, because of course you then can't use your water dropping aircraft, or you may not have as much capacity to use the water in a town. That if you have to make a choice between depleting the town's water supply and using it to fight a fire, that's never a good decision to have to make. But that's not really the primary consideration. That's kind of a secondary one. The number one issue is essentially that water in the reservoirs does not translate to widespread landscape level water available to plants and plant material, flammable dead and down vegetation on the forest floor or something like that, that would become fuel in a fire. So that's the main reason why it's not as relevant as a lot of folks might assume. A couple of comments about stingrays already out at the beaches. The warm ocean temperatures are concerning. I will probably see lots of exotic, subtropical, maybe even some tropical species making it north along the California coast, because these are really warm water temperatures, and also we expect them to persist for longer. And I didn't show this actually, but if you look at the Scripps Pier webpage, you can also look at subsurface temperatures. And interestingly, we're currently experiencing record-breaking warmth at the bottom of the shallow ocean near the Scripps Pier, as well as the top. So it's actually not just this lens of really warm water at the top. It's a pretty thick layer of very warm water, which means it's going to be more persistent, it's going to linger longer, and it's probably going to have more effects on marine species, because it isn't something that you can escape just by diving down a few feet. It actually looks like it's a pretty deep column of anomalously warm water as well in the vertical sense. As another comment, last time we had the warm ocean blob off of Scripps, there was a huge pelagic crab die-off at the beach, and other sea creatures suffer from the disruption. And upwelling being the process that brings cooler and nutrient-rich water up from the deep. This marine heat wave, if it persists for as long and as intensely as is currently in the cards, according to predictions, is going to probably have some major implications, not just for people who live near the ocean, which it already is, but also, as it drags on for months, probably marine ecosystems as well. And I'm not a marine biologist, so there are others who can answer that question more directly. But this is the kind of persistence and magnitude of marine heat wave that would start to cause significant impacts on marine ecosystems, given what's already happened and what is expected to continue. All right, here, let's see the last opportunity to get a question in under the wire. Feel free to submit one, but I'm about to get close to the end here. Doing a little bit of minor content moderation as well as I go down the list. Oh, we just got a bunch of new comments. All right, so let's see here. Okay. Liam asks, what is preventing the upwelling along the California coast that would lead to cooler ocean temperatures? Any updated indications on how current temperatures will impact coastal summer fog? Well, part of it is just the lack of northwesterly winds along the central and northern California coast. So I've discussed this in previous sessions, and maybe I will again closer to peak marine layer season in the spring. But essentially, you have winds that blow from the northwest to the southeast, roughly parallel to the northern 2/3 of the California coast. Obviously, the California south coast has an inflection point where the coastline turns more east-west from about Point Conception east to LA before it kind of turns southeast again between LA County and Orange County and then Baja. But for the northern 3/4 of the state, those northwest to southeast blowing winds actually induce offshore surface flow of water. So it actually, to the 90 degrees to the right of the wind is the force that wind pattern exerts on the ocean. And so the water at the surface is getting pushed to the west, while to the east is the continent of California and the land. So just so that ocean water doesn't continually decrease at the height of the ocean, you actually have to have water that fills the void coming in from somewhere else. And if it's going from east to west at the surface, and you can't add water coming from the east because that's where the land is, mass continuity, the continuity of mass, means that water must come from beneath. So the water comes up vertically from the deeper ocean, the colder, nutrient-rich, deeper ocean. This is why the water temperature off of San Francisco near the Farallon Islands is counterintuitively cold for its latitudes, because you have all of this direct vertical upward movement of really cold, nutrient-rich ocean water from the deep. That gets inhibited when we have a lack of northwesterly winds, which we do under a big strong ridge like we've had recently. In coastal Southern California, it's a little bit different. Here, there's also a lack of upwelling, but there's also the water kind of sits around more because it's in a more protected region. And so there, the direct effect of really hot air, direct sunlight on the surface ocean, the lack of wind, the lack of mixing is allowing that surface ocean to just heat up through direct contact with the hot air above it. And also because there's a little bit of a northward transport of warmer water from more tropical regions from the south. So it's a combination of factors in Southern California. Northern California, it's more a lack of upwelling. Southern California, it's lack of upwelling plus some other things. In terms of marine layer, I do think this means the marine layer will be much less pronounced this year than it has been in recent years, which means the coast will not be nearly as chilly in spring as early summer. In fact, it may be conspicuously warm. You might still get some foggy days or some marine stratus days where the fog is higher, but it will not be as bitingly chilly. In fact, especially in Southern California, some of those foggy marine layer days may actually be kind of uncomfortably muggy. And I can remember last time this happened, actually, I was living on the west side of LA, and I would go on beach runs along the Santa Monica beach path when the air temperature was around 70 degrees and the dew point was also around 70 degrees. Turns out that's actually really uncomfortable. It's really grossly hot and humid, it feels like. Of course, it's not hot in an absolute sense. It's been much hotter this week. It's been 90, 95 degrees at the beach. But you haven't been at 90 degrees in the fog, and that moisture makes a big difference. So it's quite possible that we'll see a summer like that with those sort of hotter, steamier conditions along the beach and the lack of the biting chill, but maybe less of a marine layer overall, a less foggy, a less chilly marine layer. That's kind of what I'm thinking right now. Marie comments, a buddy of mine took the year off to go skiing, and he is pretty disappointed. Yeah, unfortunately, this probably wasn't the year, but it's hard to know in advance. Other than that, in the long term, we are seeing much more frequent poor snow years, but we're also, as I mentioned, seeing pretty good snow years, even great snow years, at about the same frequency that we used to. So we're seeing great snow years still, but we're seeing far worse individual snow years in between. This year is a bit of both, in a sense that we had some extreme individual snowfalls, but the overall snowpack is terrible. So I guess your mileage may vary. Michael asks about fire season. I talked a lot about fire season in the last session, so I'd encourage folks to check out that recording. I just don't have time today. I'll talk more about it in subsequent sessions as well. Milana asks, as you said, this winter has been a record breaker looking backward. Do you expect this to be more common than not going forward, or is it too soon to say? No, unfortunately, it's very clear where we're headed. We will see more winters like this one, both in terms of record warmth and very low snowpack. That is just the reality. In fact, within my lifetime, easily, we will see winters that are far warmer than this one, and snowpacks that are significantly lower, although at a certain point, with snowpack, that is what's known as a zero-bounded quantity. Unlike with temperature that can continue to rise, I wouldn't say completely without bound, but it's not hard bounded at a particular value. The snowpack can't go lower than zero. And I do think we will see, if we don't reach there this year, and we may, at least in some lower elevation basins, zero SWE on April 1st, we will certainly see seasons with zero SWE in the future. But again, that does not mean that every season will be like that. In fact, I would expect to continue to see some seasons that have very high snowfall for some decades to come, some really good snow years, but we will also see years where snowpack is even worse and temperatures are even warmer than this one, because of course both of these are part of a sustained long-term trend caused by global warming, and that global warming is continuing to escalate and will for much of the rest of our lives. Now, I hope that it escalates less than it could based on future reductions and eventual zeroing out of carbon emissions, but the reality is, over the next few decades, we're going to have additional warming. Winters like this will become even more likely and eventually will become relatively close to the norm. That is what the data show at this point. But don't forget, earlier this year, parts of California had their record wettest start to the water year ever observed since the 1800s, October through December. Santa Barbara, Ventura, LA counties, Kern County, either the wettest or second wettest start, respectively, in most of those counties that we've ever observed. That, too, will become more common. So in those places, it was both the warmest start to the season on record and the wettest start to the season on record. So it does not mean that the water will stop coming in some form, but it means it's going to come increasingly in larger, more inconvenient and sporadic bursts, and also increasingly in the form of rain rather than snow, even in the mountains, all the while it gets warmer. It is decidedly a different problem than the tap completely shutting off and getting no water at all. I do think that's something that people worry about, and it's not really what we expect to see. But it brings its own problems, of course, as we're seeing this year. Axeman Joe mentions this has been the most depressing winter here in northern Utah I've ever seen. 2018, 2015 winters were bad. Nope, this is the worst. I'm just hearing that from people all around the West. Again, with the exception of Washington State in some places and like northern Idaho, western Montana, that's pretty much what I'm hearing from everybody. And in California, the only season that people can remember that was as bad as this one is 2015, but that was a year where there was very little overall precipitation. And we may get past that point for April snowpack this year. Okay, so I think I'm going to wrap up. I just wanted to offer a little bit of hope. We do have another week of record-breaking heat across a lot of the West. It won't be record-breaking at all times. Coastal California is going to be on the fringe of this third to fourth wave of the heat wave, but it will be warmer than average, and some parts of California will once again break heat records. Probably not all-time March records in California this time, but it may well be back to all-time monthly March records in Arizona, New Mexico, Utah, Colorado, and adjacent states. So this event is not over yet. April 1st snowpack numbers are going to be deeply alarming and have major implications for water supply and wildfire risk. I'll talk more about that in the future. There is going to be some modest relief, though. Early April, the odds of some precipitation and significantly cooler temperatures for about a 3 to 7 day period, 3 days if we're unlucky, 7 days if we get lucky, does look like it's in the cards, but it's not going to be an awesome April rescue miracle or anything like that. But it certainly will be different and improved in many ways from what we're seeing right now, which is a sustained multi-week period of record-breaking warmth, record-breaking unprecedented rates of March snowmelt, and no precipitation at all. Early April will be a bit wetter, will be significantly cooler. I'll take it for now. All right, I'll see folks. I will be traveling later this week, so I probably won't have an update, but I will try to have one by early the following week, perhaps Monday or Tuesday next week, and then also probably a Weather West blog update before, hopefully, what still appears to be a decent pattern change. I'll probably try and have that out Saturday or Sunday before the change actually takes place next week, assuming it's still in the cards, along with the Snowpack update at that point. So thanks for your attention. As always, the session will be recorded and available as soon as I press the end stream button. And oh, by the way, I did have a comment after the last session regarding the closed captioning on these sessions. Many of you who are using it now have probably noticed that there is automated live closed captioning available via YouTube while I'm live, as right now, for example. Once I end the stream, there will be a brief window of about an hour to 2 hours in length when the closed captioning goes away while the video renders. YouTube uses a higher quality algorithm to recaption the recording of the video thereafter. And that does become available for anyone to use in closed caption form on the recording beyond that point. So there's like a 1 to 2 hour window immediately after the live stream ends that the closed captioning is not available, but I do have it enabled on all of my videos and on all of the live streams. There's just that window. So either try and catch it live if you want to use the closed captioning, or wait an hour or two and then it will appear again at that point. And finally, there is, and this is true I believe on all YouTube videos these days, an automatic transcript. So if you want to read a transcript of the whole session, and I know journalists have found this useful to pull out quotes, that's another useful resource that's available too. I would ask that if you're going to quote me on something directly, to use the transcript to go back to the point in the video when I actually said it aloud, because the auto transcript is pretty good, but it's not 100%. So for direct attribution, that would be my advice, but otherwise, have at it. And in general, as I pointed out previously, since I've gotten a lot of emails this week about this, you, if you're watching this, have permission to use the content of these videos, the audio, the visuals, the quotes that I say in whatever form you want. So it's essentially open access, and that does include anything for journalistic purposes, media purposes, and let's call it limited commercial reuse. You can't take all this and put it behind a paywall and charge money for it, but anything short of that, I think, is reasonable, fair game. So please feel free. All right, I'll see you all next time.